In the last episode, I showed you guys how to use Neat to create a neural network that plays Sonic. We are done with that part. The tutorial 2 function, which I will upload to my GitLab repository, will do this over time. Once it one of the problems is we currently have the config feed forward in the config file set to some insane number, 100,000. That's not, we can't use that. 100,000 is never going to happen. But what we can do is we can add a point where if he hits a certain X value, we can add 100,000 to the fitness, and that way it'll work pretty good. There's also some functions built into here to see if he gets to the end of the level. I don't remember. Yeah, screen X end. So we can use this function. Okay, let's actually do that right now. We're going to grab this guy, screen X end, and we're going to put that into our network. We need a new variable. Where can we put this? I don't really know where to put this. We'll say X pause end equals 0. Okay, that's what we'll use. X pause end equals info dot. Again, that's the variable name directly out of our data file. We set these. I'll do a different episode on just that if you want. Yeah, so this value here is the final X position in the first level. It'll change per whatever level you load, so it's kind of handy to set it like this because it's dynamic. And what we're going to do now is here, if X pose is equal to or greater than, how does this work? Greater than, equal to? We'll just do equal to X pose end minus, we'll say 200. Sometimes that's the way to do it. Give it some running around room. Heck, no, fuck it. We'll go straight. We'll go all the way. We'll go hardcore. I should probably print out what it is to make sure it works. I've never tested this. We're doing this on the fly. If X pose is equal to X pose end, we're going to do fitness current plus, excuse me, 100,000. That's what we've set in here, right? 100,000. So basically, if the X pose equals that, the fitness current is 100,000. And I guess we can do done equals true as well. Okay, so if he gets there, he adds that much to the fitness and he's done. And that will end our neural network training because we have solved the problem. We've achieved the end of the level. This is the end of the level function solving there. Okay, next thing I wanted to do was add in a little bit of statistics because Neat comes with a bunch of stuff you can read, some outputs and stuff like that. I'm just going to copy paste these in here and I'll explain them afterwards. So we have P here is our population. So P add reporter standard output true stats neat.statistics reporter. P add reporter stats, so basically this guy and this guy. And then you can also do a checkpointer. So this means every 10 generations save a checkpoint. This is helpful if you find you want to add something to your program but you don't want to lose the evolution that you've currently generated. So now we should be able to see what that happens. To just make it quicker, I'm going to make the population size 5. This is not what we're going to run it with. I just want to make sure that the output is clear. So let's see what happens. Okay, so right off the bat, you see it says generation 0. That's really handy. Now it's going to go through all 5 of our genomes and then give us some stats and start the second generation. This will be more helpful. Okay, apparently the generation I've done something wrong because the second one got 100,000. So I'm a good programmer, guys. That's what this is proof of, that I'm Champion programmer. How did he get 100,000? Well, he achieved. So as far as the AI is considered, he got the highest score possible and is done. So it exited. Something's wrong. If x pose equals x pose end, is that because he ran to the left? Let's do and x pose greater than, we'll say, I don't know, 500. This is bad programming. Okay, I guess maybe the left side of the screen is the same as the right side of the screen. I don't know, it's confusing. Maybe I got the wrong variable. We'll find out. It's all good. I guess we could print out the result. Okay, so generation 0. First one, oh, they're doing pretty good actually. This is a good random genome. So this is all from scratch, eh, guys? Like every time you start this over, you start with no connection, well, partial connections between your input and output. Come on, make it up the hill, Sonic. Do it. Nah, he doesn't know what he's doing. 420 though, that's pretty good. It's a good result. I'm going horse, guys. I can't talk anymore. Come on, Sonic. Hurry up. Okay, so he's going left. Let's see if that crashes everything. Nope. Okay, so good. So here's all our statistics. We got average fitness of 145. Best was 420. Some adjustments and stuff. Population of 5 and 2 species. Remember, because we set it to 2.5, so we have not that many. 3 go to the first one and 2 go to the second. Total extinction 0. Generation time 49 seconds, and then it starts the second one. And what it's going to do is it's just going to keep going until it achieves the goal of Sonic getting to the right side of the screen, at which point it will exit. How cool is that? It's extremely cool. It makes me really happy. I don't know why. It just does. What else can we do? Oh yeah, we got to write. We want to, when it wins, when it's done, we want to save the network so that we can load it and play it back for other people so they'll believe us. Right? If any of you guys get Sonic to beat the first level, I want to see it, because what happens to me every time I do it is he gets to the first loop-to-loop, and he cannot, for the life of him, figure out how to get through the loop-to-loop. At one point in time, he glitched through the bottom and got past it, but I didn't save the network when he did that. It's very unfortunate, because it's the only time it's worked. Yeah, duck Sonic. That's gonna get. He's real scared. Scared of flowers. Okay, so we're going to stop this. Actually, I guess we just let him run in the background for now. See how he does. Maybe he's going to get real good. We're going to add some... We're going to pickle the winner. Okay? So, did we import pickle? I don't know if we installed pickle. Actually, I don't think we did. I'll write it anyways. So with open winner.pickle. You can call it whatever we want, but that's what I'm going to call it. We're going to write binary as output. Pickle.dump. If you guys don't know how to use pickle, go to the documentation. It's very, very good for neural networks. We're going to dump the winner output 1. Okay, so that's going to save our neural network to winner.pkl for us. It's unlikely that, I guess we can set the, if you want to see that happen, I guess we can do that. I don't want to kill him because he's doing so good. Okay, so he stagged twice there, but this guy got to 420. Anyways, that's pretty much everything. If you guys want to see what the neural network's doing, I can do that too. Let me just copy paste in some stuff for you. We're going to use OpenCV for this. So with OpenCV, you have to make a window. We're going to turn off the rendering of the thing because we're going to make our own. And we're going to add a couple of variables here. These do the same thing as the other one did. They're just separate variables. And then we are going to show them. So you can look up all this stuff. This is just standard OpenCV stuff. We have taken the input image OB, we've changed it to, we actually only, oh, we should make this to gray so you can actually see what it is. And then we've scaled it to the same size. This is the same stuff. So this is what the neural network's actually seeing. Every frame looks horribly like this. So you can kind of make out Sonic, you can make out stuff that moves. That's how the network will, that's what the network will learn on, this input. So I'll cancel that, we don't need that. I like to make it RGB, so it's a little bit clearer. It's not actually what the network sees, but it's sort of prettier. Yeah, that's all. Just a scaled down version of this stuff. You can scale it to whatever you want, whatever works best for you. I divide it by 8. That just is really good for me. What else? Okay, so we're not going to use that. We'll go back to render. It can be handy to run this without render on. You don't actually need to render it to get the results. It'll still go through the, oh, excuse me, the window. You can run this in the background without the output, and it'll just keep going until it achieves the goal, at which point it'll pickle the file for you, and then you can write a separate script that'll load the pickled file and run it for you with the end render enabled. So yeah, we get 179. It'll just go through this stuff. This is good so it doesn't distract you while it runs in the background, because it's probably going to run for a couple hours. Turn that back on for now. Is there anything else that's a good idea to show you guys? I think that's it. If you liked this, please send it to people. Tell people about it. Feel free to comment with any questions you have. Feel free to comment with judgment of my programming ability. It's subpar, I know. It's fine. Oh yeah, if you want to change it to anything else, you can just do like this. So there's Green Hill Act Zone 2. Or whatever you can set. You can create any. So here's the second level. Yeah, way to go, Sonic. It's just gonna. That looks like a glitch. Yeah. Oh, wow. These AIs start good. Yeah. Go, bud. Is he gonna beat the second level on the first generation? That would be great. No, it's gonna get stuck here because they cannot handle these hills. I don't know why. Yeah. And you can actually just change it to different games too. You probably, if you have, every different emulator has a different default resolution, so you need to calculate this value again. And if it's the NES, it has 9 outputs instead of 12. The Super Nintendo also has 12. So you need to change these values basically if you want to use one of the different emulators. But we can pick a different game and run it on that. And no, you'd have to change the X value here too. You don't have to use this exposition stuff that I used. You can get rid of all of this crud. Get rid of this crud. Where can we get rid of this crud? Just get rid of all this and just do fitness current plus equals reward. And that's just going to add the reward output of the environment to the thing and then do all this for you. That should work too. Yeah. That makes it more generic. So then you can change it to a different game. I'm trying to do this in under 15 minutes. Oh my god! Where's the thing? What's another Genesis game? Genesis. So where are we going here? Gym Retro, Data, Stable. Real Monsters. Oh no, I probably don't have that one installed. Let's just do Sonic 2. So you can change it to any game you want, but we'll do Sonic Hedgehog 2. And we need to know what the state of that is. There's no time left. Sonic. And, oh, that sounds like a terrible level. Aquatic Ruin. And now this should just work on a separate one. Yeah, so there you go, Sonic 2. Basically, this is a generic framework for using Neat. Again, you have to change the inputs and the outputs if it's going to be a different emulator in a different game. And you're definitely going to want to look at the reward functions for each one, because don't forget the scenario and data files will be different for different games. So it's really important that you do that. I'm going to do one more episode of this where I show you guys how to calculate the RAM values and stuff. I'm going to try. It's really quite flickery on mine, so if it's clear in the video, I'll use it. If not, I'll just explain. Okay, later guys.